Hi guys, and welcome to a new tutorial of Blender and Geometry Notes. Today we are going to create a vector viewer or vector helper to help you visualize and analyze distance between points, edges or faces, or getting normals and tangent information to visualize in your viewport. So let's get started. I'm using Blender version 3.3.1 and go up in the plus button, General Geometry Nodes, add a single mesh with the Shift A plane is a good choice. Press New to create a new Geometry Nodes modifier. And for this tutorial I will show you how to make your vector viewer, and in the final part of this tutorial I will show you some cases where you can use this group node and to better understand why I created this group node. So first of all we need an arrow, and we will create an arrow with a head, and the total size of this arrow will be always 1 to be used as a unit measure in our scale to visualize the correct distance between 2 points. So we will have an arrow like this from one point to another point. This part of the arrow will be a parameter that will be able to manipulate, maintaining always this size to 1. Now I will hide the annotation. Now we can create the arrow by a single circle curve, Shift Alt and click. We can decrease the radius to 0.1, for example. Press 1 to see the result in the front orthographic view. Now we have to fill the curve with an hexagon, for example. Then we have to extrude this mesh up to the z-axis, uncheck the individual check. So keep in mind that we want to extrude on the up direction, so I will add a combine XYZ, set 1 to the Z and link the vector to the offset. I want to extrude edges. Here we have a problem, so if I enable the face orientation you have the opposite normal that we want, so I need to flip these to get all blue colors of the normal. With this button you can enable the snap tool in the geometry nodes. Now we need to extrude another time the edges of the top of the previous extruded node. Next we need another extrude node. Press 1. We want to select only the top selection, and another time we want a combine XYZ to indicate that we want to extrude to the z-axis, to the positive z-axis. And finally we can merge by distance only the top edges we extruded at the final step, and we can select these connected edges with a distance number height to create the arrow. Now we can select all these nodes, press Ctrl G to create a group node, and we can export some values to manipulate our parameters. So we can export the resolution and the radius of the arrow. We can rename it in thickness from 0. Now we can export the head thickness, so this part of the arrow, head thickness from 0. We can export this last extruded value and we can call it head length from 0 to 1, maximum 1 value, and we can use a subtract node where we want to use this value 1 minus this head length, so 1 minus this length, to get the rest of the value of this trunk length, so the total number will be always 1. Now we can press tab to exit from the group node. We can decrease a little bit these values like this, for example, and you can see we have a problem of merging vertices here, so we can enter in the group node and we have to adjust this value. We can use the head thickness, so the distance between this point and this point, add the thickness of the trunk, so we can use this add node, add the trunk thickness and multiply these by 2 to always get at least a number that can be greater or equal, in this case, this distance from this to this, to let us merge these vertices together. So we can link this to the distance and this is the result. We can increase a little bit this number to be sure to have always a value here to get a correct merge result. So 2.5 for example. We can collapse these nodes and this is the the final layout of the arrow. Select all these nodes, Ctrl J, F2, single arrow. We can turn off the face orientation, press Tab to exit from the group node, rename it in vector viewer. Eventually you can set the shade smooth to off and increase your resolution if you want, depending on your performance PC. Now we can decrease the thickness of the trunk a little bit and the thickness of the head, and this is our vector. If I increase or decrease the length, the entire scale of this arrow will always be 1 for our purpose. Next, to use this arrow, we need source points and destination points. We will calculate the distance between these points and the different vector created by the vector of the destination and the source points. I will show you how. If you have a point here and a point here, when you get position from geometry nodes, you have the 3D numbers of the vector in the space starting from the origin point of the environment. So we have this vector for the point A and this vector for the point B. So if we want the different vector between this vector, you have to subtract the A vector from the B vector. So in this case, I want to have this vector here. This is vector C. The vector C is equal to the B vector minus A vector, because we want to visualize this result. But keep in mind, if you calculate this formula, you always get a new vector that has new information always from the origin point. So we will have a vector like this with the new information of X, Y and Z. So in some cases we will need to shift the result vector here to the source point of the source positions. So I can hide the annotation, and now we can create a group input to have the source position and the destination positions. They are vectors, so we can click here and create move up. We can call it sources, and this is vector. These are vector and destinations. And to let us choose the sources from a base geometry to have a more easy selection of the source points, we can add a geometry input here, base geometry, and a boolean value, or calling it source from base. So in this way we can choose directly the points of the base geometry and not a custom source points. Or instead, we could use a custom source points to have our arrows. Now, to manipulate the positions of the source, we can use this source from base in a switch node, when we can decide what vectors we want. So if the source from base is switched on, we want the position of the original base geometry. And why I indicated the position here? Because we have a set position node, because we want to start with the points of some meshes. I could use the points node, but because we added a source from base, why not using a base geometry that already has source position to have the start point of all the arrows? So we can drop this node. If we have a source from base, we want the position of the base geometry, so I can link this output to the position, or otherwise in the false we can directly link the custom source position. I can collapse this node, Ctrl H to hide the attributes we are not using, select all these nodes, Ctrl J, F2, choose source position. Now we need to instantiate the arrow on these points, so we can easily drag this node instance on point and link these with the Alt right button to instance on point. Link these to the group output. We see nothing because we are not a base geometry attached to our group node, so press tab to exit. Link the base geometry we created in the base geometry of this vector, and you will see with the plane 4 instances of this vector, because we have a plane with 4 vertices, and all the 4 vertices are starting from the same source and goes to the same destination, but we are not using destinations yet, so we can enter in the group node, and basically we want to use a destination on our arrows. To do this, we want to rotate the instances along the direction of the vector described before, between the destination destination and the source. So we have to add the group input here and subtract from the destination what the source we chose here from this part of the layout. So I can drag these to this H to collapse this node, and we can use this in an align Euler to vector rotation because we want to rotate the z-axis of the base of the arrow, so this axis, to the vector of the difference between the destination and the source position. So we have to link these to the vector and use these to the rotation of the instances. Now to see this result, we have to exit from this tab and we need to set source from base, and you can see all the 4 points starts from the source point of the geometry input and goes to the same destination here, the 0, 0, 0. And if I move this value, you can see all the arrows follow this destination point. Okay, enter in the group node. You could also use not this attribute rotation, but you could use the rotate instance if you want after this point, and link the rotation not here but in the rotation of the rotate instances. But keep in mind that you need to turn on the local space to get the same result. Now I drop this node and use this rotation attribute because it's more easy. I drag this a little bit, drag this a little bit. We can select this, Ctrl J, F2, vector direction from source to destination, and we can select these, Ctrl J, F2, rotation. Now we can scale these arrows depending on the distance between the source and the destination points. So to do this is very simple and easy. We can also add a new group input and a new attribute that we can call normalize. It's a Boolean attribute, and we can use it to choose if we want to scale the vector of the true scale or the true distance between the destination and the source point, or a normalized value. So if the normalized is true, we want one scale for all the arrows you are seeing in this moment. Otherwise, we want to calculate the distance. So we want a vector math node here, select the distance between 2 points. We don't need a vector, we want a single value, the absolute distance between 2 points, and use it with this false between the source and the destination point. This is the distance, and we can link this to the scale value of this instance on point. We can select this, Ctrl H, and why not? We can create a useful custom float value like a custom scale that we can use for our purpose from 0. And now you can use this output, normalized or not, that we can scale by this new value. So I can duplicate this and link this custom scale here, use it in this node H to collapse this node and drop this dot, Ctrl H, Ctrl H, Ctrl H, Ctrl H to show and hide the attributes that we are not using. We can select all these nodes, Ctrl J, F2, scale vectors and normalize. Save the project. Now that we have the scale, we also need a new Boolean information here in the attributes, because as described before, if you have a shape like this and you want your vector start from the origin and go in this direction, it's easy. But if you want to visualize the information of a tangent of a point, the tangent information is already a result vector. So if I want the tangent of this vector, imagine that you have this tangent. Blender gives you this point, but not this point from this source point. Blender gives you this point from the origin, so you will have this vector, so this point in 3D space. And if you linked the tangent attribute of a base geometry in the destination of our group node with the source from base checked, so turned on, the result will be this vector here, this arrow, this physical arrow, so the source point to the destination of the tangent information that starts from the origin of the environment. And you don't want this shape, you want a shape like this. And to do this, you have to add from this vector point the source point position. So in this case, you will shift the vector from this origin to this origin, and we will get the correct shape of the arrow here. So for the normal and the tangent information, this is the only cases you need to use the new attribute, the new Boolean attribute that we will add now in this geometry node layout. So we can turn off the annotation, go to group, and we can add here a new Boolean information like norm and tangent use, and we need to manipulate this new switch here before the calculation of this subtract node. So I can drag this in a switch node here, and if the norm and tangent use is false, I want to use the original destination here and use these for both of these nodes, here for the different and here for the calculation of the distance that we need to scale the arrows. Otherwise, if the norm and tangent use is switched on, we want to add from the destination the source we have here, we chose before, and then use these in the switch node. We can collapse these, create adults to help us understand the layout, Ctrl H to hide the unused attribute here, and this is the final layout of this selection. So if the normal and tangent use is switched on, we want to add the source to the destination point to have the correct shifting of the vector of the tangent or normal on the source position of our base geometry or custom source position. Otherwise, we will use the same custom destination we linked in the group input of this group node. We can select all these nodes, Ctrl J F2, choose add source to destination, save the project, and finally we can save the information of the vector in the 3D space between destinations and sources to see it in a shading editor. So to do this, we need to set material. Here we can create a new material called vectors, select these from the graph, and we want to store the name attribute here like vectors. We want to store the vector information of the difference between the destination and the source position, so the final result of our arrows, and we can link these directly to the store name attributes like this. And then to see this attribute in the shading editor in a correct way, we need to realize instances here, because we don't want shift Ctrl and click. We don't want instances, but we want mesh. We want the shading editor work with the mesh result of these arrows. We can drop these, and we want to save the information not for each point, but for each instance before the realize instance. So in this way, you will get a single color information. Each arrow, an arrow that goes in one direction, will have a single entire color depending on the direction of the vector itself. You will see better in a moment. We can select these nodes, Ctrl J F2, assign material, and save color by vectors. Now that we have all the group we want, tap to exit from these. We need to assign a custom scale here by 1 for the default value. Tap to enter in these, and go to group, custom scale, default value 1. So if you import this group node in your layout, the default value will be 1. The head length 0.3, for example, head thickness default 0.1 and 0.03, for example, for the thickness. Now we can go in the shading editor. We can use the principal BSDF shader, add the attribute node. We can set here the vectors attribute from the geometry we saved before, and we can link these directly to the base color, and this is the result. Now if I don't use this principal BSDF but a simple diffuse BSDF, I can link these and use these for this purpose. Drop these. You can see this weird effect. Why? Because if I jump in these geometry nodes, tap to exit from this group node and join these together, I can assign set material to our plane to see the result. If I create a new material here and select these, okay, perfect. You can see this. If I have a vector going to the x-axis, we will have a partial information of the color. So the unique positive number of this vector is the x, and because the y value is negative, the shading editor will give you black information of this axis, black color of this axis. And for the same reason, this color has two parts, one in this direction and one in this direction. So this is a positive y and this is a negative x. So for the negative x, the color is black because there is no information in the UV map space that you can use in this case for this purpose. So to avoid these problems, we need to calculate the absolute number of these vectors. So you see the arrows like this, but to get the correct colors of these arrows, we will jump in the shading editor here, select the vectors, and we will calculate the absolute value of this vector, and not only this but also a normalized value to get always an information that is always 1, and this is the result. So if I jump to the geometry nodes again and delete the annotation here, now if I increase the destination and go up here, or for example I increase the x value here or decrease now the z, you can see this result. You have the color of the effort of the single partial axis values of your arrow. If I move these to 1, for example, move the x and y to 1, you can see this correct result. I have here one vector with only the z information and no information about the x and y, so no green or red information but only a blue information. And if I decrease this to 0, I have this information, only the information of this x-axis for this arrow and the green axis for this arrow, and this lets you understand the position in the space of your arrows and your vectors. There is a last important attribute, so we can jump here in the instance on point and we can add a group input node and export the selection point that we want to visualize or analyze with arrows. Ctrl H to hide the rest of the attribute we are not using, and now the group node is ready to use. Now let's jump to the practical cases. First case, point to point. So here we have a mesh with 5 vertices starting from this point, then extruding this point here, then here, then here, and then here. Now if I unmute this geonode system with M, I have the group input, the base geometry here, and then we see that it goes in the vector viewer and then in the join geometry. So I want to have a vector between the 0 and 1 index. So what can I do? I want to get the position of the 0 index of this geometry. So this is the transfer attribute, and I want to link these to the source of this vector and the destination point, so the index plus 1, so 1 index to the destination, and this is the result. If I want to show the vector between the 1 index and the second index, I can set 1 here and set 2 here, and this is the second vector, all up on the z-axis, and so on. If I want to link the 0 index to the second, I set these to 0 and these to 2, and this is the result. Color between red and blue. So next step, if I want to link all the source position to the position plus 1 of each index, I can have this layout. So I can link all the index in the sources and all these index plus 1 to the destination, and this is the result, an arrow following the creation, the sort of the index of these vertices of this mesh. And if I want to know how a mesh grows in a viewport, you can select as the base geometry the mesh you want. So for example, a cylinder, and in this case you can see that the cylinder borns here and the increasing over the index for the entire mesh. Or you can set an icosphere, for example, and this was the case 1. Next case, curve to curve. So in this case I have this layout. I have 2 curves here that I can move as I want. We have 3 little nodes here to resample the curve by an integer number that we can manipulate, and I want to show vectors between the resampled index of this curve to the resampled index of this curve. So here for this curve I have 0, 1, 2, 3, 4, 5, etc. to 16 in this case, and next we have from these 17, 18, 19, 20, etc. index on this curve. So to have this result, we need to use the source position of the base geometry. For example, I check this source from base to already have the same points of these curves. But for the destinations, I need to transfer the information of the original position, adding the maximum resample value here, because otherwise we will have 0, 1, 2, 3, 4, 5, etc. and 0, 1, 2, 3, 4, 5, etc. for this second curve. But I want a continuous sequence of index for both of these curves. So in this case, the destination will be 0 index, adding 16, so this index. The next will be 1, add 16, equal to this index. And to limit the making of the instantiating of the arrows, we will use the selection attribute, setting the index when it is less than the resample. So if I decrease or increase the resolution, you will have the total correct arrows on our shape. And I can change the position of this control point, and you can see the color changes depending on the direction of each arrows in the 3D space. This was the second case. Third case, stars, normal and tangent. We have a star here and a little star here. So the first that is translated in this position, and with a little scale values here, all joined together. Now we want to have the vectors from the start of this star to the same index position of the second star. To do this, we need the position of the original base as the source position, or we can leave this source from base, for example, and link the transfer attribute of the position of the second star to the destination we want to show. Now you see these because there is the norm and tangent use, so I deselect these, and this is the correct result we want. If I check normalize, you can see all the vectors are normalized, and I can use the custom scale to scale up or down all the vectors. I set these to 1 and deselect the normalize. And now if I want to show the vector of the tangent of each single point of this first star, I need to link the tangent information to the destination point. So you can see the wrong result, because if I press 7, look at this point, we have a tangent like this, okay? But because the tangent information doesn't start from this point but starts from this point, we have this point of the tangent. And if you look in detail, you will see this shape here goes from this source point to this destination point, and this is wrong. We want to have this representation of the tangent, and to do this we need to set the norm and tangent use to shift this destination tangent position to this correct position, adding the source position, okay? And now you have the correct tangent information, and if you play with the parameters that define the star, you can see the changes on the tangent arrows. If you want the normal, it's the same approach. So if I link this to destination, this is the correct normal of each point. If I deselect this normal, you can see all the arrows goes to the correct axis of the normal, but in this case all the normals starts from the origin point to the space, to the rest of the space. So I check this and this is the correct result. And this was the third case. Now case 4. This is a simple mesh created extruding the edge of these single faces through the space and so on, and I want to see the flow of the index of this shape from 0 to the maximum index of this shape by this vector viewer. So how can I do this? It's very easy. I have the base geometry here. I want to set the source points here. I want to transfer the vector information of each indexed point, and in this case the position, and I can link these to the source position and the source point adding 1 to the destination, and this is the result. But I can get the same result selecting not the point but edges here and here, and this is the correct order of indexing the edges on this surface. Or I can select face here and face here, and this is the order of the creation of these faces. And you can see you could probably use this information to get average information between two faces for your purpose. Okay, so this vector already has the information of the angle and the distance information between this point, and you can store this information in a new attribute for each faces to use next in your project. So I remember you that if you want to import your vector viewer in your project, you need to create a new file or open your project file and use this link or append menu, select the blend file that contains this vector viewer, open the subfolder node 3 and select vector viewer node. This will automatically add the vector material. That's all. Thank you guys for watching this video. I hope you like it. You can download this project from my Gumroad page or create this group node from your own if you want. In the downloadable file you will have not only the group node but also the cases described in this tutorial. If you like what I'm doing, please subscribe to my channel and make sure to check the bell icon to get notification of all new posted videos, and see you to the next tutorial. Bye!